அனைவருக்கும் வணக்கம். வெல்கம் டு அதர் tutorial. ஸோ நம்ம இந்த வீடியோவில் சாப்டர் 1 தான் டிஸ்கஸ் பண்ண போகிறோம். ஸோ in this video we are going to focus only about the board exam based on chapter 1 numerical except NCERT exercise as well as example numerical. So most repeated and important numericals. So I have shortlisted 13 models based on the chapter 1. So now I am moving to the first one. For solving the numerical, we have to follow one trick. First one, we have to shortlist the given information. Second one, we have to identify the formula. Third, we have to substitute. If you following these three steps, entire numerical will be easy. Let's go to the chapter 1, the first numerical. So first one, 3 point charges, 1 picocoulomb each. That means they given 3 charges, all are same value. So given informations are, we have to write Q1, Q2, Q3, which is equal to 1 picocoulomb. Pico means 10 power minus 12 coulomb. So next they identify vertices of equilateral triangle. The side is 10 centimeter. So we have to focus in terms of SI unit. So A is nothing but 10 centimeter, which is convert into meter. So 10 power minus 2 meter. So finally we can write 0.1 meter. So next they are asking about to find the net electric field at the centroid of the triangle. So centroid of the triangle. So first we will draw equilateral triangle. No need to draw that during exam. For our understanding concept, I am drawing. So this is maybe the centroid point. So based on this, they are asking what is the net electric field. We can assign the name. For example, Q1, Q2, Q3. The side is nothing but 10 centimeter. So I'll give the name A, B, C, D. So we have to find that net electric field at D. So this is the one they are asking. So electric field at D is equal to what? So now I am going with the solution. Solution, we know that electric field formula KQ by R square. So based on the given information, we can get electric field due to first charge, which is equal to electric field equal to second charge and third charge. The reason is the distance of centroid triangles are equal and charges are same value. So first we will calculate the distance. So distance from each point, from each charge to centroid. So we know that formula for finding the triangle centroid, where class we may study, the distance R is equal to side by root 3. That is nothing but A divided by root 3. So A is in terms of meter is we have 0.1 meter. So 0.1 divided by root 3. So this is nothing but the distance. Now we can substitute here. So E1, E2, E3 we need to calculate. So all are have the same value. So no need to worry about that. So directly we can write E1 which is equal to E2 which is equal to E3 which is equal to, use the formula. This formula K Q divided by R square. K value is nothing but 9 into 10 power 9. No need to use K is equal to 1 by 4 pi epsilon naught value. Directly you can substitute the value of 9 into 10 power 9. Then charge value is nothing but 1 into 10 power minus 12. And the distance is nothing but 0.1 divided by root 3 whole square. We have to simplify this. 9 into 1, 9. Into 10 power here plus 9 minus 12 is there. So you have to add. Finally you will get minus 3 divided by 0.1 whole square. So if you do this 0.01 divided by root 3 is nothing but 3. So you have to multiply. So this 3 will go to numerator. 9 into 3 into 10 power minus 3 divided by 0.01, which is nothing but 10 power minus 2. So 27 into 10 power minus 3 into 10 power 2. So finally we can write 2.7 Newton per coulomb. So finally we got that the net field due to each charge is 2.7 Newton per coulomb, but our aim is to calculate the entire point due to Q1, Q2, Q3. What is the D? So listen, this is the point D, the direction of field. So this is the positive charge. So the direction of field will be this direction. Similarly for Q2, it will come like this, it's going with Q2. Similarly for Q3, the direction will be this direction. That means positive charge. Positive charge means the field will be outward direction. So you observe here, the angle between each field is nothing but 120 degree. So we have one symmetry property. So based on the vector, based on the symmetrical property, so angle between each field is nothing but 120 degree. So if it like this, you won't get any field. So imagine you are here, the three persons are pulling around 120 degree with the same force, we can't move, correct? The same concept due to symmetric property. So theta is 120 degree and E1 is equal to E2 is equal to E3. The net resultant electric field at centroid is 0. So like this we have to conclude that. So E resultant is 0 Newton per coulomb. So I hope it's very clear. So now I am moving to the second concept. The second one, a particle of charge 2 microcoulomb, mass is 1.6 gram, it's moving with velocity 4 meter per second. That means that particle is moving in x-axis. At t equal to 0, the particle enters in a region. So when we have the t equal to 0, it starts from x. Having that electric field E is given 80I plus 60J Newton per coulomb is given. Find the velocity after time particle of 5 seconds. So now we studied about the final velocity, initial velocity in your first chapter, but we studied in lower class. So first we'll sort out the given information. So given charge is nothing but 2 microcoulomb is nothing but 2 into 10 power minus 6 coulomb, and mass is nothing but 1.6 gram. We have to convert into kilogram. For that we have to use gram to kilogram conversion, 10 power minus 3 into kg. Next, velocity initial at t equal to 0, that means initial velocity is nothing but 4I meter per second. Okay, we have to indicate. Then given another thing is nothing but electric field E is equal to 80I plus 60J. Clear? So at time equal to 5 second, they are asking that final velocity is nothing but V. Okay. So we have the formula in lower class. We may study that V is equal to U plus AT for the straight line motion, S equal to UT plus half AT square, and V square is equal to U square plus 2AS. These three equations we used. But they are asking about the final velocity, so we can't use this equation. Second equation we can't use because they didn't give about V. So only the possible is first and second equation. So for this time is given, so we can use this one Here distance is not given, so we can't use third one. So only possibility is first equation. To find this, we have to go V is equal to U plus AT. So U is given, A is not given, T is given. So we have to find A, what is acceleration of the particular particle. So mass is given, E is given. So what is the relation? Like that we have to take based on mass, based on electric field as well as the charge. These three terms are given as the information, but we have to relate. But we have studied that force is equal to Q into E. So now we can take force is nothing but mass into acceleration into Q into E. Now calculate A Q E divided by M. So now if we are relating this, all the given informations we can fill. So charges is nothing but 2 into 10 power minus 6. Electric field is nothing but 80 I plus 60 J. And the mass is nothing but 1.6 into 10 power minus 3. So 2 divided by 1.6 and 10 power minus 6, 10 power minus 3. After that we have to multiply this. Correct? Yes. So that's it. So first we will go with 2 divided by 1.6. If you do this, we will get the value is nothing but 1.25. So 1.25 into 10 power minus 3. So 80i plus 60j. So now we have to multiply 1.25 into 80. If you do this, we will get 100 into 10 power minus 3i. Then plus 60 into 1.5 is nothing but 75 into 10 power minus 3g. Okay. இப்போ நம்ம என்ன பண்ண போறோம் அப்படின்னா ஜஸ்ட் இதை வந்து ஆக்சலரேஷனை கண்டுபிடிச்சிட்டோம். ஸோ இந்த ஆக்சலரேஷன் தான் வந்து என்ன பண்ண போறோம் அப்படின்னா சப்ஸ்டிட்யூட் பண்ண போறோம். ஓகேங்களா? ஸோ v is equal to u plus at. So we have to substitute that value. So u is nothing but 4i. A is nothing but 100. These things we can take it as 10 power minus 1. So minus 1i. So these things we can write as it is. So or we can write, okay, we will leave it 10 power minus 3j multiply with t, that is nothing but 5. Clear? So now we are going to multiply this 4i. So 5 into 10 power minus 1. So 5 into 10 power minus 1i. 75 into 5. So 75 into 5 we have to multiply. If you do this, we will get 375 into 10 power minus 3j. So finally we can write 4i 0.5i plus 0.375j. So that's all about the final velocity. So directly we can add it 4i plus 0.5i then 0.375. So if you add this, finally our result is 4.5i plus 0.375g. So this is the final velocity of given particle is moving with this much velocity. Okay. So now we are going to the third concept. So third concept is nothing but based on the conducting plate. So look at this. A point charge plus q is kept in the vicinity. So vicinity is nothing but near or approximately of an uncharged conducting plate. That plate is nothing but conducting. It may be square or rectangle, whatever. Sketch the electric field lines between the charge and the plate. So first we will draw a plate. So this is my conducting plate. For example, I can draw like this. So this is my conducting plate. So nearby I am going to place a positive test charge. This is nothing but Q. So whenever you are placing a positive charge, if you are having a conducting plate based on the induction method, the opposite charge will be induced. So based on the induction property, so one side of that conducting plate there may be a negative charge will be induced. If negative charge induced here, the same way the positive charge also induced in another side. So based on this, we need to draw an electric field lines. So positive charge means radially outward, so it will move towards the negative charge. So like this we have to draw. So that's all about this solution about the third concept. So now we are moving to the fourth one. The fourth one, a charge having the magnitude. So the charge is given has the magnitude is plus q. Is divided into two parts. One is q and minus q minus q. So that is nothing but we have two charges. The two parts exert a maximum force of repulsion of each other. Then find the ratio of q minus q. So they mentioned about the maximum force, repulsion force only is there. So based on that, they are asking about the ratio of capital Q divided by small letter q. So based on this, we need to identify the given information. So is first q is nothing but capital Q. Another charge is nothing but q minus q. They given clearly maximum repulsive force. So we know that based on the Coulomb's law, K Q1 Q2 divided by R square. This is the formula. But they didn't given about the distance, but they are asking about only the ratio. Okay, first we will find that repulsive force. So K Q1 is nothing but capital letter Q. Q2 is nothing but Q minus Q divided by R square. If you do this, okay, so you will get, sorry, we did wrong. So in this case, the first charge is nothing but they have taken the q. So this one only divided. Okay, this magnitude is nothing but capital letter Q. So here we have to make q. So if we multiply this, k q into q minus q square divided by r square. So this is the repulsive force. Clear? But they are asking about the ratio. But the given the one condition is nothing but it exerts a maximum force of repulsion. So we may study it for maximum force is nothing but df by dq is equal to 0. So based on this scenario or based on this condition we are going to solve. So d by dq is nothing but k q into q minus q square by r square is equal to 0. So k by r square is nothing but constant we can take outside. So k divided by r square we can take outside. So d by dq is nothing but q into q square is equal to 0. So if you are r multiplying 0 you will get 0. 0 by k also 0. So finally we will get d by dq is nothing but q into q minus q square is equal to 0. So now I am going to solve here. So we need to differentiate. So look out here, here the function is nothing but q. So here q is there, we can possible. Here q square is there, so we can differentiate. So finally, if you do with individually d by dq minus d by dq into q square is equal to 0. If we do this, we will get q minus 2q is equal to 0. Q is equal to 2 into small letter q. So finally they are asking about the ratio capital letter q divided by small letter q is nothing but 2. So this is the ratio value. Clear? So now I am moving to the fifth concept based on the chapter 1. So what is the electric flux? They are asking the flux based on the E value is given 3 into 10 power 3. I also given. So that means electric field is moving through x-axis through a square of side 10 centimeter, then it's held to normal to E. The square is kept normal to E. So first we will go for the given information. So given E is equal to 3 into 10 power 3 I Newton per coulomb. And the square side is nothing but 10 centimeter. So we need to convert into meter. So 10 power minus 2 meter. So they kept normal. Okay. So we know the formula. Flux is nothing but E into del S, or we have flux is equal to, based on the Gauss law, Q by epsilon naught. Here charge is not given, force is not given, so we can't use, only can use this formula. For this we have to go for E into ds into cos theta. Electric field is given, area we can calculate it, angle we have to focus. Correct? Okay. So first we will find the area vector angle. So this is your x-axis, is moving with electric field. So we will take the reference frame. This is x, this is E. They are mentioning 90 degree is nothing but a square. So this is the field, means this is the 90 degree. Based on this, they kept one square. So they are asking about flux through this square. So this is the field. So we have to imagine. So electric is moving towards our right hand side. So when you are placing a square 90 degree, okay, so it may be towards our electric field. So based on this, we need to calculate that area vector. So if you are drawing area vector, that means something with 90 degree we have to draw. So it will come along with that electric field. Finally, theta is nothing but 0 degree. So we have to write E is nothing but 3 into 10 power 3 I. Area we need to calculate is nothing but square, so a square only. So is nothing but 10 power minus 1 is nothing but 0.1 meter. So 0.1 whole square into cos 0. So question is I. So finally we can write 3 into 10 power 3 is nothing but minus 0.2. So finally 3 into 10 power 1 is nothing but 30. So unit is nothing but electric field is nothing but Newton per coulomb. Area is nothing but meter square. So finally the flux through the square is nothing but 30 Newton meter square by coulomb. So now I am moving to sixth concept. So this is very important one. Consider two halos concentric sphere S1, S2 enclosing a charge PQ for Q respectively as shown in the figure. Okay, so maybe the figure in below. Okay, figure is not in given, so we'll draw the figure, no problem. So find out the ratio of the electric flux through them, and how will the electric flux of the sphere, the dielectric constant epsilon r is introduced space inside the S1 in place of air. Deduce the necessary expression. Okay, so first we will take the hollow cylindrical sphere. This may be S1 and this may be S2. So we will take S2, S1. So the S1 is filled with TQ. So this entire charge is nothing but 2Q. And we have another charge, we have another constant sphere. It has the values is nothing but 4Q. So this is filled with 4Q. So this is nothing but S1, this is nothing but 4Q. Find out the ratio of the electric flux. So for sphere we can go with directly Gauss theorem. So first one I am going here. So for flux through surface 1 is nothing but Q by epsilon naught. Q is nothing but total charge. Total charge by epsilon naught. Total charge is nothing but Q divided by capital Q by epsilon naught. Similarly, while coming for surface 2, so Q by epsilon naught. So here also we have to calculate the total charge divided by epsilon naught. So total charge we have to add 2Q plus 4Q divided by epsilon naught is nothing but 6Q by epsilon naught. But the question is nothing but they are asking about the ratio of the electric flux. So flux through surface 1 divided by flux through surface 2 is nothing but 2Q by epsilon naught divided by 6q divided by epsilon naught. So epsilon naught q will cancel, 2 by 3, 2 by 6 is nothing but 1 by 3. Therefore flux through surface 1, flux through surface 2 is nothing but 1 by 3. So this is the ratio. I hope it's maybe clear. So now we are coming here. Second part. Second part, what they are saying, they removed this here in this one. So based on this, they are introduced dielectric constant. It's nothing but relative permittivity. So if relative permittivity is mentioned, so we have to check the absolute permittivity. So we may study that relative permittivity is nothing but absolute permittivity by air permittivity, that is epsilon naught. So when you are introducing here, the flux through the surface 1 is nothing but q by epsilon naught. So q is nothing but dq. Instead of epsilon naught, we have to take absolute permittivity is nothing but epsilon r into epsilon naught. So this is the expression for that particular surface. So this is the expression. Clear? So now I am moving to concept number 7. So this is very important numerical. So for identical point charges Q, each are kept 2 meter apart. So we have that point charges Q are kept 2 meter apart in air. A third charge Q is unknown magnitude and sign is placed on the line joining the charges such that the system remains in the equilibrium. So when you are placing your charge, again it gets equilibrium only. Find the position and the nature. Position in the sense distance. Position means we have to calculate distance. Nature means we have to calculate either positive or negative. So now we will go for to find that nature. So this is the positive charge. This is another positive charge. They kept 2 meter distance. These are the points mining charges. When you are placing Q, if Q is positive, so what will be happen? We'll check out. This is a positive charge, the field will come radially outward, this also will come radially outward, this also will be radially outward. So all are opposite directions, so we will get repulsive force, it won't be any equilibrium condition. Same way we will take negative charge, so what will happen? We'll check out. So this point I am going to place a negative charge here. This is radially outward, positive charge is radially outward, but negative charge is radially inward. So both are in same direction. So finally Q is negative, then only the system will be under the equilibrium condition. We found that the magnitude we didn't calculate it. The nature of the Q is nothing but negative. So now we will go for the distance, that is position. So for that we can easily calculate it. There is nothing but force on each charge, that is under equilibrium condition. Due to the positive charge, due to the another positive charge, we need to calculate. If we do this, we can easily calculate. So based on the force, the first charge is nothing but kq1 q divided by distance r square. Similarly, q2 is nothing but kq2 into q divided by r square. So like this we have to plan and we have to calculate. So now we are going to solve the distance. For this I am going to take that. This is q. This is another q. We have the distance 2 meter. So based on this we are going to take a one particular point here. So this is the q. I have placed at x. Based on this charge is nothing but 2 minus x is the distance. So we have to substitute. So k q divided by x whole square is equal to k q divided by 2 minus x whole square. So everything will cancel. we have 1 by x square is equal to 1 divided by 2 minus x whole square. So cross multiply this. So 2 minus x whole square is equal to x square. So we can easily simplify, or we can go for square root. So I'm going to take the square root. If I take square root, 2 minus x is equal to x. So 2 is equal to x plus x. 2 is equal to 2x. Therefore x is equal to 1 meter. So if it is like this, if q is placed at 1 meter distance between two charges, the system will be under equilibrium. That means we have to place this charge midpoint of these two charges. So we have to write the conclusion. Negative q, okay, should be placed midpoint between two charges. Like this, we have to write the conclusion. So remaining concepts we will discuss in part 2. So kindly subscribe our channel Agnes Tutorial. Thank you children.